Not so long ago, newspaper want ads were segregated by sex. There were male jobs and female jobs, and that was that. Today, that kind of blatant segregation has ended. Women make up about 45% of the workforce, and they do just about every kind of job.
So they're just finishing the operation ahead of us.
But a more subtle kind of equality is still an issue: getting comparable pay for comparable work.
What can I get for you?
In this unit, we'll see how a single statistic, the median, was used in a successful effort to achieve comparable pay. While graphs help us see the big picture, we'll see in this unit that using numbers enables us to describe data in more specific ways. First, we'll use a number to describe the center of a set of data. We'll learn that the median measures the center of a distribution by splitting it into equal parts. And we'll learn about another measure of center, the mean, or average. Histograms like these picture the distribution of values of a variable. The top histogram shows the weekly wages for American men. You can see that it's skewed to the right. Most men make moderate salaries, while a few make much more. The bottom histogram shows the same information for women. This distribution is even more strongly skewed to the right. These pictures are helpful in comparing the typical wages of men and women in the United States. But pictures are seldom enough. We also need to describe situations like this with numbers. In particular, we need a way to describe numerically the center of distributions like these. A good way to measure the center of skewed distributions is with a statistic called the median. The median splits a distribution in half. Half the values lie above it, and half lie below. The median weekly earnings for men in 1988 was $449. Remember, this means that half of all men earned more than $449 and half earned less. The median weekly wage for women was only $315, about 70% of the figure for men. The disparity in wages between men and women is real, but the situation is complex. Some of the difference is accounted for by differences between men and women in education, age, and years of service. Another major reason for the earnings gap is that women tend to be concentrated in lower-paying jobs. Are the jobs women take on worth less in some sense? Or are these jobs lower paid because they're primarily held by women? This is the central question in the debate over comparable worth, the idea that men and women should be paid equally, not only for the same job, but for different jobs of equal worth.
Relations, this is Linda.
It's a question that was hotly debated in the city of Colorado Springs, Colorado. As part of its normal operation, the city government evaluated all municipal jobs with criteria such as working conditions, skills, and accountability required. The jobs were given numerical ranks. It turned out that many clerical jobs, mostly filled by women, scored the same number of points as operations and maintenance jobs, which were mostly filled by men. But the median wage of the men's jobs was always higher than the corresponding median for the women. This evidence was used by a group of city clerical workers to pressure the city for a more equitable pay structure.
Once we had the statistics, then we could actually prove that the clerical employees were being underpaid.
The hardest part was trying to convince the City Council and the administration that this was something that was fair, that needed to be done.
But the numbers were hard to argue with. The clerical workers won. The city agreed to equalize the median salaries for jobs of comparable worth. The plan had an unanticipated benefit. The relatively high turnover rate in jobs held by women was reduced.
Because you know that someone appreciates what you do and rewards you accordingly, you do your absolute best for them and you go the extra mile.
You pay fairly, you pay appropriately, no matter what the gender, and you'll find that you have high productivity, high morale, low turnover, and we have fewer employees per 1,000 people served than most cities. So I think it was a good business decision, in addition to the fact that it was just basically fair.
The ability to describe the Colorado Springs income data with numbers, specifically medians, was essential in achieving fair wages for men and women workers. To learn how to find a median, let's create a small business, one with only 19 employees. Here are their weekly salaries. The whole collection of salaries forms a distribution. It ranges from an entry-level wage of $250 a week to the president's hefty $1,500 a week. But as was the case in Colorado Springs, what we'd really like to know is what the typical wage at this company is. In other words, we want to find out the median wage. Recall that the median is the value that splits a distribution in half. Here's how we find that number. The first step is to arrange all the observations in order from the smallest to the largest. For small data sets like this one, that's not too hard. For larger sets of data, this can be the most time-consuming part of the process. Now we're going to count halfway up the ordered list to find the median. We need a rule to tell us how far to count. Here it is. Count the total number of observations. There are 19. Then use this formula, n plus 1 over 2, where n is the total number of observations. Because n is 19, our formula becomes 19 plus 1 divided by 2. That's 20 divided by 2, which is 10. So we simply count that many places up from the smallest observation in the series. We count up 10 places from the beginning of the list. And we find that $450 is the median salary in our little company. You can see how this procedure carries out our definition of the median. $450 is the central value in this distribution. There are 9 lower salaries and 9 higher. Now, in this case, the total number of observations was odd, 19. That meant that when we counted up 10 places from the beginning, we landed on $450, which was our median. But what if we had an even number of observations? For instance, what if we had 20 salaries? Then n plus 1 would be 21, and 21 divided by 2 is 10 and a half. Well, that puts us right between the two middle values. Since there isn't a value already there, we just find the midpoint between the two values on either side. Here, the two values are $450 and $400, and halfway between is $425. So $425 is the median wage in this distribution. That's all there is to finding the median. The 3 steps are arranging the values in order, using the formula to find out how far to count, and counting up the correct number of places. Now, what about the other measure of center, the mean? You already know the mean by another name, the average. To average a set of observations, just add them all up and divide by the count of observations. Here is a shorthand way to express that operation. Suppose that our variable is called x. Then the traditional symbol for the mean is called x bar. To find it, add up all the observations. The sigma x stands for add up all the values of x. The Greek capital letter sigma is an instruction. It means to add up everything that comes after it. Then we divide that sum by the number of observations we have, which we call n. Let's find the mean of the wages in our little company. First, we'll find sigma x by adding up all the individual salaries. That's 11,200. Then we'll divide by the number of values. That's 19. The result is a mean company wage of $589. And that's quite a bit higher than the figure we got for the median, and nicely illustrates the differences between these two measures of center. The median relies on counting the ordered observations, and thus gives a feel for a typical value. Half the observations lie above it, and half lie below. The mean, on the other hand, takes into account the actual numerical values of the observations, not just where they lie in a ranking. This is an important difference. Because it's calculated from all the numbers, the mean is heavily influenced by very high or very low values. For example, let's give the president of our company a hefty raise to $3,000 a week. Changing just this one wage causes the mean company wage to increase almost $100, from $589 to $668. That could give a false impression of how well the company pays, since we didn't give a raise to anybody else. The median, however, is resistant to such changes. It isn't sensitive to extreme values such as the president's new salary. Because the number of salaries hasn't changed, the median hasn't changed either. It's still $450. This example reminds us that the mean and median represent two different ideas, and so they don't need to agree. The median is the midpoint, while the mean is the average. The median resists a few extreme observations, while the mean responds to them. There's one common situation in which we don't have to think about the distinction between median and mean. The two measures of center have the same value when a distribution is exactly symmetric. The mean and the median of a symmetric distribution both fall at the point about which the distribution could be folded in half. Of course, distributions of real data aren't exactly symmetric, but many are close enough for the difference between mean and median to be small. The mean and median are the two most common ways to numerically describe the center of a distribution. That's a big step from just picturing a distribution with a graph. But the center is just one important aspect of a distribution. The spread is equally important. Do the data cluster tightly around the middle, or do they spread out? So while describing the center is important, it isn't the whole story.